Okay, we're going to get started, everybody. Thank you all for joining us. Just take off screen for a minute. We're really excited to have our first Toronto chapter of the CSNP, cybersecurity nonprofit. For all of you joining, again, welcome, and thank you very much for being here and for joining really something new and exciting that we have started here. Just a little bit about the CSNP. The cybersecurity nonprofit was started down in Chicago a year ago, 2 weeks ago. So it's a year and 2 weeks old. And really the goal of the CSNP is to make cybersecurity education and training free and accessible. And it's really there so everyone can protect themselves and their organizations from cyber threats. And we are passionate about building a supportive, diverse, and inclusive cybersecurity community. So as we grow and as we expand, please also take a look at all the other chapters throughout the US. We have one in Africa, one in India as well. Support them all. Take a look and join with everybody. My name is Lee John Scramstead, and I'd also like to introduce my partner in this venture, Johnson Bouthia. He's here now too. Johnson, would you like to say a word?
Yep, can you hear me?
Yes.
That's awesome. So yeah, my name is Johnson Boothia, and Lee John, as LJ said, I'm his partner in this whole thing. We're very excited to bring this amazing organization to Canada. Obviously, it's a first, but not one unique thing that's happening in Canada in the space, in the cybersecurity space. But in my more than 15 years career in cyber, this is probably the most amazing thing I've done so far. Proud to be part of a very exciting venture to bring cyber for the average Joe to Canada and in the form of a CSNP. So I hope this first session and the number of members that we have so far proves to be a successful venture for us today.
All right.
Jay.
Thank you very much, Johnson. A little bit of housekeeping. We apparently do this for every webinar. Again, thanks everyone for coming. I've told you about CSNP. Today we're going to be hearing from Jake King. He is the co-founder and CEO of CMD. Today he's going to talk about best practices for understanding who is in your cloud, the good guys and the bad. So without any other preamble, because we don't need to do anything else, I'm going to pass over to Jake. Two reminders though. If you have any questions, click the Q&A button. Put down your question. We will get to as many as possible towards the end. And also, there's going to be a little bit of a special treat for everybody that attends today. So if you see people or you know people that may not have joined yet, get out, reach out to them however you can, communicate and get them on this webinar, and we'll be able to get moving. Take it away, Jake.
Thank you, Lee. Lee John, it's wonderful to join the call today and wonderful to be part of a kickoff of an amazing group. CSNP is obviously really trying to evangelize security insights and really kind of share a lot of this knowledge around. And I'm excited to see this this part of the community start to thrive. A little bit about me. It's great to meet you all. Sorry, you've got the side profile. I'm in a very, very small Vancouver apartment. So hopefully you can hear me fine and see me fine. But today we wanted to talk a little bit about, who's in your cloud and a little bit about me, because I'm not just a non-experienced security person. I've been in security for around 10 years now. And I've been focusing most of my career on SecOps and penetration testing with a very large focus on Linux endpoints and systems. I'm one of those folks that's fortunate enough to call themselves cloud native as well, which is a pretty interesting topic, specifically when I kind of got my first gigs. I was working with virtual systems or cloud systems throughout my entire career. And for the last few years, I've been working with, obviously with a group of really talented engineers, salespeople, fantastic folks at CMD, where we're experts in the Linux process space and experts in Linux security. And we've been building out CMD since around 2016. So I've been working on the problems around Linux security and Linux system hardening for quite some time. So hopefully you find today pretty compelling. So what I wanted to do was first and foremost cover what we're going to be talking about today. You know, a lot of these presentations kind of tie into very vendor specific solutions. While I do work for CMD, while I do build my technology, I wanted to share things that are open source, free and available, and obviously things that you can leverage as part of the smallest cloud deployment if it's the very first time you're doing something, all the way up to actually pretty large deployments of cloud environments. I wanted to start with the basics though. So I do want to explain some of the details around the different types of SaaS vendors, the different kinds of cloud providers, understanding the cloud security controls that are in place, understanding who's in your console, and obviously then getting into who's in the compute as well, with some tips along the way of how you can add some controls in to actually learn a little bit more about securing these kind of systems. To give everyone also a bit of a clear understanding, this isn't a deep session. I'm trying to make this as accessible as possible, so please feel free to ask any questions as we go along. If I don't see them in the chat there, I'm sure one of my friends on the call here will let me know, but at the same time, happy to answer any questions you might have at the end of the presentation. There's also a few open source projects that I'm talking about in this project that I'll make sure we share out the slides for after the presentation, so you can click and explore and see some of those details as you go through in hardening your own systems. But I also wanted to come at this in a bit more of a broader sense to let you know how we're experts in these systems. When it comes to hardening cloud environments, outside of just hardening the instance and infrastructure, at CMD, we've been very proud customers of Google Cloud Platform, or GCP for short. And we've been running our workloads in not only Google Cloud, but Amazon for a number of years. Because we've been so focused on host-based security, we've actually had to get really familiar with a lot of the cloud infrastructure controls that are out there as well. And thankfully, as a small company, specifically a Canadian company, we've found we've flown under the radar for a lot of adversarial attacks. And so getting early security kind of steps in place for us was not only really rewarding, but it's been incredibly efficient for us. And really the basis of a lot of these talks and topics start from hundreds of thousands of unique interactions with our systems and really on an hourly basis. So not only from the host instrumentation that we collect on behalf of our customers, but the host instrumentations that we collect from our own systems internally. So hopefully you'll get a bit of a balanced approach in today's presentation. So without further ado, I'll get into a little bit more of what we're going to talk about. And really, I love to start with a slide like this to really get an understanding of what's going on out there and understanding the threats that are pertinent to you. Sometimes we're just home hobbyists. We're deploying a system to play around with the cloud. Sometimes we're in information technology or public sector or retail or healthcare, and really understanding the threats that are pertinent to not only our environments ourselves, but the kind of adversaries that might be targeting us are incredibly important. One of the fantastic resources or great resources that I've found is the Verizon DBIR. And so you can kind of see a couple of the different trends that people are seeing in the environments today. But I like to talk about this because it's really interesting to see the kinds of adversarial behavior, the kinds of attacks that we're seeing in the industry. External attacks are pertinent in the information sector, while public sector targets tend to be more internal. And actually the kind of things that are going on with those environments are going to be a little bit more specific. So really starting out with any kind of security initiative, as any good security initiative starts, is understanding the systems, but applying controls and policies and the things that you need to worry about in a way that makes sense to your vertical. Sometimes we need to go further than we typically would. So it's important to consider the risks and obviously kind of counter those risks with different controls that we can put in place. But really going from that threat landscape, it's important to understand also where the control points that you have inside the systems you own are going to be. It'd be awesome to think about physical security if you own a data center, and very important. But if you're deploying an application in an IaaS provider, an infrastructure as a service provider, some of the networking, storage, servers, and virtualization are already covered for you. One of the great things about cloud is not every kind of deployment is equal, and not every deployment is going to have the same controls. But one of the great diagrams that I've found from BMC here was actually talking about the kind of different things that are going to be managed by the cloud provider themselves, and the kind of things that you are going to have to consider as someone using that cloud environment to understand when those lines of delineation tend to be. We're thinking of this in kind of a really clear way, but the best way to explain it is security of the cloud and security applied to your cloud. So the orange areas of this visualization show the security of the cloud, the things that are set as defaults, the systems being locked up in a data center, the power management, deployment of disks, the maintenance and management of firmware and infrastructure within those environments, all the way down to who owns those security bounds and the things that you should be concerned about. And it's important to know which kind of deployment you're running into when you're thinking about cloud, not only from a host-based perspective or from a runtime perspective, but just understanding the risks that are going to be pertinent to you. We can only assume trust to the boundaries that the cloud service providers offer. And it's beyond this that we have to kind of implement our own security controls, and often through best practices and aligned with what we've found as interesting in our vertical as a really great way of thinking about it. So if we take this one step further, one of the big things that I did want to mention is in the last few years, it doesn't take far to kind of glance around and look at what's available to you in the native cloud security consoles that you're going to have today. What we're finding is that there's not only a huge amount of accessibility and tooling inside the platforms as they've started to mature, but the really nice treat about competitive nature in this industry is that every cloud provider wants to be known for something, and security is part of that something a lot of the time. CSPs have been providing services to extend the coverage of security controls and logging and monitoring and open source tooling for many, many years. But it's only in the last few years that controls have actually started to become really exciting. And one thing that started to also become very interesting is cloud service vendor lock-in isn't so much of a big concern for a lot of folks now, as a lot of the systems that you're going to use with one cloud vendor are interoperable with others. But it's important that as you start to think about cloud controls and cloud security, you've got a really good balance of what you actually need to own and what you might need to go to external parties for or build yourself if you do have plans to use non-compatible cloud security providers, cloud security vendors. So when we think about this, it's really important to start from fundamentals. One of the things that you probably didn't expect to hear a little bit about today is IAM, Identity Access Management. And in cloud, we've got to think beyond just the system control and constraints, and we've got to look to what's available to us to control the fabric of systems running. So when we think about system access and security, traditionally we've looked at locking down the data center, locking the door, making sure that the network is secure and we've got a strong password. But with IAM inside of the cloud, access is extended beyond, far beyond and above the kind of things that you would normally kind of assume. IAM now no longer only provides the ability to start services, stop services, access the firewall, make changes to systems. It actually, even in some cases, provides you the ability to provision credentials onto a host, get access to a runtime, or even manage and back up data and disks and storage in a way that could provide some weaknesses to your security strategy. So all the way down to that instance, you've got security concerns at that IAM layer. And often when I'm speaking to companies that are going down the line of understanding identity risks and access management, I was finding that IAM was a big complex topic that was never really getting uncovered. And the later you leave looking at this solution, the greater this problem starts to become. So as we started to get in here, we wanted to not only understand who was doing what in our platform at CMD, we wanted to implement some best practices around controlling these kind of controls. So we have a small group of engineers, they're DevOps engineers, and they operate as SRE, reliability, and really engineers that are fantastic at maintaining and managing our cloud infrastructure. This is a quick example of the complexity of one of the roles of a user within that fleet of systems. Not only do we have the ability to give them access to different functionalities within that cloud, but we have the ability to grant and remove permissions for their user account in a pretty powerful way. One of the biggest challenges with IAM, though, is really understanding the internal roles and mapping them to responsibilities within your company. If you give everyone allow rights for everything, you're going to have a very large problem on your hands when you've hired 15 more engineers or added 10 extra people to the platform, and you're trying to figure out why a system might have broken down or changes might have been made. Reviewing IAM controls is a fundamental part of cloud security, and it's taking a number of the tools that are open source and available to the community to understand the kind of things that you might want to look out or consider to apply a policy in a really consistent way. One of the best ways to think about this, though, is looking at a real attack. Now, this is a kind of specific attack that's leveraging, a basic kind of stage deployment. DevOps manager is assigning a role for an engineer. The role provides them API access with administrative administrative provisions to the console. The developer discovers that admin access and that extended access, and then might choose to abuse one of those privileges. Perfect example of this is over provisioning an intern in your organization with the ability to delete files or systems. It's probably not the best thing in the world. While they might need access to start servers and test infrastructure, when they get in there and they might inadvertently or purposefully abuse a permission, it can be really, really complicated. So one of the tools that I've found incredibly useful, and I've actually done another presentation on this, we'll include it in some of the notes and extended reading in the presentation here, is actually a presentation that I made at Google Cloud, one of the events in Google Cloud in New York a few years ago, talking about an open source tool called Forseti. And Forseti's been around for a number of years. And what it does is it allows you to apply policy constraints and warnings around the kind of permissions that any engineer in your environment might need or might have. Forseti is a powerful platform that not only allows you to identify the risky permissions of the engineers that are accessing the fleet, but it lets you create policies that will alert you and notify you as someone provisions an account. They might overextend the permissions. And again, it lets you really build a solid repertoire of understanding what risks you're capable of accepting in your environment and the kind of things you may want to avoid. So in this example, we're going through a DevOps manager is assigning the developer role to one of our new developers on a team. Let's call him an intern. A role is provided the engineer with G-Cloud access within the approved scope, because Forseti's described the kind of role that we should provide that engineer. And beyond that, because we've provisioned the correct permissions, we can anticipate and understand the scope of what that user can do within the system. It's not anything complex. It's really just making sure that that delete function might be removed, instant start, the kind of complex things that we all think about day to day might be removed from that kind of risk profile for us. We're effectively decreasing the risk and increasing the scope of coverage and getting alerted when things tend to go wrong. Forseti is something we use internally at CMD for assigning and applying config policies. And we actually use this under the guise of SOC 2. We like to apply best practices and standards when it comes to securing our infrastructure. And we've used Forseti to build reports and obviously describe the instances and the environment that we've got running in CMD in production in many other environments too. So taking this a little bit further, some of the lockdown mechanisms you can actually implement are really kind of native. When we're looking at Forseti, the ability to report on different kind of permissions and profiles, there are some really amazing guides and material that you can take advantage of. Azure has some fantastic best practices, tutorials, and some videos on YouTube. AWS and GCP both have enterprise hardening guides and best practices guides, but it's important that you read these guides and understand the scope of what's going on. If you're not implementing the best practices and the guides as you go and following those trends over time, your state's going to diverge from the best practice. You're going to find weaknesses in the system, and often you're going to expose yourself to unneeded risk. One of the big things that I'd also encourage you to do is watch for notifications from the cloud providers. When a new service or a system is added, best practices might be assigned to, say, a data storage service, a new database offering, or even a container service offering that you might be wanting to leverage. It's important to know that each time you're deploying a service, you consider that cloud, kind of security delineation. Does a cloud service provider own all of the security for the stack? Or is it something that they own to a certain point, and you can transfer to different people within your organization to take on that risk and ownership yourself? So if we think a little bit further along, there's one other part to the system that we've got to think about beyond just console access. The ability to start services, stop services, do different things is part of the risk. But one of the big trends and topics that we've seen over the last few years, and it's actually something that I've taken part in personally over many, many years, is exposure to different services. When we think about the cloud, we've got to think about the assets that are within the cloud, that we're running within the cloud. We can't just consider that there's a specific topic or a specific consideration of a potential host or a database or a service that is going to be off limits to adversaries. Understanding the scope of what you're exposing to the internet is incredibly important. And while there's lots of tools that'll tell you what's out there and potentially when you've exposed something abnormal or unusual to the internet, it's really important that you can keep a constant eye on the kind of things that are getting started in your infrastructure to get ahead of these attacks early. So a perfect example of this would be exposure of, exactly in the screenshot, an S3 bucket within AWS. I'm sure many of you have heard about data exposure or data leaking, but this is a really common example. It's an older example, but a really common example of a very large vendor deploying assets in cloud and sharing information in an S3 bucket inadvertently. Now, thankfully, there's some amazing tools for this as well. One of my favorite tools is a platform called Cloudsploit. While this is their fancy SaaS offering, basically what this tool provides you the ability to do is look at asset exposure. What are the configurations beyond my user permissions and policies that I can apply as a centric policy to lock down the assets in my environment? Perfect example in this case is actually talking about logging. It's telling us that there are reasons and gaps in our environment, our hardening policies that aren't following best practices. And again, these tools are free and open source. You can grab Cloudsploit from GitHub, run it yourself, run the standard policies, and actually align your environment with best practices. I've found not only is Cloudsploit fantastic for looking at the assets within your environment and the exposures there, but in AWS and GCP, it provides some insights that Forseti does as well. And it can be a really powerful tool for you to take advantage of, albeit not so pretty if you're not paying I think the $15, $25 a month that I pay for my personal account, but I've been using it for a few years. It's super usable, super insightful, and something I'd highly recommend you take a look into. But we can't stop there. When it comes to cloud, that one highlighted item in that case was actually logging. And it was not only logging for the cloud console itself, it was logging for a very specific service within cloud. When we consider the kind of things that become incredibly important for forensic analysis, we've got to consider the kind of things that we've got after a breach has occurred, after an abuse has happened, after something has gone horribly, horribly wrong. When we're looking at the cloud service providers offerings by default, often what we're finding is that there's some awesome capabilities built in, but you've got to remember to enable them. How many times have we come in there and seen that there's no logs when there's a breach that's occurred or an issue that's happened? Defaults are really usually limited, not only to save costs, but to make sure that when you're going into those services or into those environments, you're setting them up in a way that makes sense for you. Not necessarily just forwarding them to a log server or a bucket that's never going to be touched, getting them into a place where you can review, assess, and kind of observe the kind of threats that are there. But one really important consideration, and this was one that we brought up earlier on in the conversation, was really one around understanding the capabilities of logging of your cloud service vendor. When we're looking at the kind of things that are running within a fleet, running within an environment, running within the system, we've got to understand what the logs are going to capture and what they're not going to capture. For example, a database service. Is it going to capture the queries that are being run against that database? Probably not by default. Will it, kind of record the access management and the maintenance, the backups, the tasks that are running within that system? Absolutely. It's very important that you not only understand what the logging is doing, what kind of information you can extract from those logs, but how often those logs are going to remain consistent. Consistency is absolutely key, especially over long periods. And one of the things that I noticed really even in doing this presentation was not only that when we get into cloud service provider is logging sometimes limited, sometimes it is in beta. And beta forms and releases are very, very specific to those cloud service providers and may be subject to change over time. So if you've got an alerting policy or you've set up a log aggregation system for alerting and monitoring, that you don't want to avoid a particular event in, make sure that that event is out of beta, make sure it's consistent, and make sure it's tested and working. Because the amount of times we've seen logs go sideways, it goes horribly, horribly wrong. So taking this a little bit further, it's important to consider that one other thing that I mentioned, cloud service providers don't turn on a lot of this logging by default because it's expensive, and it can become incredibly expensive over time if you're not considering ways to efficiently and effectively store this information. Now, one of the fundamentals of cloud security is we've got the ability to store massive amounts of data for relatively cheap if we know what we're doing. This quick diagram here shows logs not only coming from GuardDuty and CloudTrail, but also GCP being forwarded into a bucket storage system of our choice. Doesn't necessarily need to be S3 or GCS, but one of these bucket storage choices is incredibly cheap and provides incredibly long retention storage, might be slower to access. The other might have a higher performance, higher aggregate volume to capture that information, to store and visualize that information, but it's not going to be something that is going to be cheap. So not only is it important to budget, backup, and plan the logging process that you're going to be putting in place, it's important to take advantage of cost-saving measures that the cloud providers give you as well. For us at CMD, we store all of our information, a lot of our logging information in GCS, low-cost bucket storage that we archive and share over time to make sure that we're not spending tens of thousands of dollars on disks that are highly performant and running in a really high performance manner when we don't need it. But contrast to this, what we also need to do is consider the kind of things that might be going wrong within an environment. When we do need to access a log, what are we going to do? How are we going to do it? Where are we going to be able to pull that information? Using hybrid logging solutions that might write to something like Elasticsearch, the open source, kind of SIEM and data visualization tool, are a really good example of this. Subset of that information could be forwarded from your existing cloud service logs using a Lambda function or a cloud function into those platforms for you to give you a high fidelity, very high performance and low response time endpoint. But again, this is kind of an important thing to think about. Everything that I've talked about so far isn't actually talking about the instance. It's not talking about the cloud runtime. And often this is where your cloud service provider is going to hand responsibility to you, especially in an infrastructure as a service manner. So, and for those on the call that haven't seen this email before, this is a pretty scary email to get. It's especially a scary email to get if it's a production instance in a production role. How do we know if we're compromised? What are we going to do if we're compromised? And has anyone received one of these emails from AWS? Now, thankfully, this example is an example from an old honeypot that I deployed in a test environment a couple of years ago. And that honeypot was compromised. The service that was compromised was running on a non-standard port on that system. And the logs monitoring and capabilities that were running on that system were really kind of blocking different access, different services and different systems in a way that was pretty interesting. What we were able to do was discern that there was bytes sent from that system, packets sent from that system, but nothing else. And if this was the only source of information I had about that host, I'd be pretty out of luck trying to figure out what went wrong. So taking it one step further, it's important to consider that compute phase of the cloud environment. And look, there's a lot of tools out there that you can leverage that are paid, open source, managed, unmanaged, even homegrown tools and scripts you can build yourself, all the way down to just pulling history and logs from the files and seeing what's going wrong. But one of the big things that I would say here is so important is not only just recording these to the system. If we're just recording these audit logs to the host and you end up with that email from Amazon, the instance is shut down, sometimes the logs are deleted by the adversary, and those audit logs that have become so large on the host might actually take down your application. So while it seems pretty basic, centralizing a lot of this information is super important, because when your adversary is logged into the system to do the wrong thing and the logs are gone, you're pretty much out of luck anyway, and all that hard work was for nothing. So let's take it one step further and understand what we can do to get some of this insight. A lot of people ask me this. Obviously, working in a company that works on log centralization and data, I could pitch you our solution, but we do want to make sure that there are a couple of things that you can do for absolutely free forever and ever and ever. So not all server logging solutions are the same. And it's really important to not only use the logging solution that's not only going to be performant for your environment, but actually solve the problems for you. Right? We want to make sure that they're going to not interrupt your workload. It's going to give you the information you need, and it's not going to be overly verbose or expensive to store. One of the big things that I often see here is it's important to take the first step in enabling some of these basics by default. So we want to make sure that you're starting logging processes in your cloud environments, in the console, as well as in the host level as soon as you really can, because you're not only going to understand more about what's going on within the system, you're going to be able to find out what was in that red box in that backup.sh being run and figuring out what might have actually gone wrong. So comparing the right data and capturing the right data is really the next most important step. Turning on logging and centralizing some of the information is a really basic way to get some insights. But what I like to see is the kind of things that you can use as an open source and built into Linux functionality. Standard solutions like auditd are going to be your kind of bread and butter kind of logging solution in the Linux world. They're going to provide you the capabilities that can record sessions and TTYs and running processes. If you're getting really advanced, you want to get kind of creative with some of the solutions out there. eBPF has brought an entire new world of really amazing observability tools that are out there today in an incredible performant way that kind of gets around a lot of the performance challenges in some ways of those solutions like auditd. But really the second two components to consider here is not only just capturing that data, but it's forwarding it on to different systems that you can then use to visualize information. What becomes important here is not so much looking at the things that we're doing on the system itself, it's making sure it's consistent. Because when we want to run a query across 30, 40, 50, 60, 90 days of data, we want to make sure that the log that was captured on day 1 is the same, or if not similar to the log that was captured on day 90. So a consideration that a lot of people often overlook is versioning, tagging, documentation, consistency around timestamps, file sizes, OS configurations, the kind of things that are going to make these logs stay the same. For example, a couple of months ago, there was some changes made to the audit framework in a number of different distributions in Linux. And not only did it break some audit tooling, it added some extra capabilities that teams weren't really obviously aware of, didn't really notice the changes in. And hey, it was pretty interesting to see that enrichment and metadata was being added to that system on the fly. But the other thing that you want to potentially do as well is look to add new information. So if we've seen a change made to an environment, for example, we've looked at a specific execution or a binary was run or a hash of a file was recorded, backfilling some information into what you're storing in GCS or in your event storage system might be a really great way to kind of add a bit of color to the kind of things going in your environment. Looking at ways to add things like geolocation to an IP or IP reputation from a database saves you from having to look this up in the future. And they're kind of things that you can add very, very simply. But you're probably looking at this and thinking it's a hugely complex problem. It's a hard thing to solve. It's really not. There are a couple of very basic tools that you can put together that are going to capture this information, even with some basic guides. We talked a little bit about Audit D. Simply following some basic guides on Amazon or GCP's blog are going to get you up and running on that in a really, really basic way. One of my favorite tools that is completely open source, you can rewrite it, you can tear it apart, you can look at it yourself, is a tool called Vector. It's built by these guys that have built this amazing platform that the only thing it does really efficiently is takes logs off a system and forwards them onto other platforms. Running a small Elasticsearch cluster is a couple of minutes to get up and running and started, and tying it to different tools like Kibana for visualization and ElastAlert for actually looking at the logs that you want to capture over time and alerting you on the bad things that are going on is going to be a really great, completely open source stack. Now, all of these components can be pulled down and leveraged in different ways, but the most important thing to consider is you can even take these products and improve them and commit back to the changes in these environments, even in GitHub as well. So they're all open source, completely free, completely usable. Going one step ahead though, and I'd be remiss to not kind of include some of our technology for free, Vector can be leveraged to capture those native log files and system files, but leveraging tools like CMD to capture some of those basic log files and forward them to GCS or your other storage solutions of choice as well can be a really effective way to get started if you don't want to go through the headache of managing things like Audit D. One of the most advantageous positions that you can have is to test and try different software though. So this isn't a perfect stack. It's just a simple stack that I run at home for one of my local systems using our free product. And it's been super effective for me. I capture information, I log and store it in CMD for high performance visualizations. I use GCS for low performance long-term queries. And I actually even use some really cool tools like BigQuery to visualize data over time. I find it pretty cool. There's some amazing guides out there and they're in the comments inside this slide as well as you go through it. So once we've captured this information, what do we do with it? How do we know it's valuable? Why is it something we actually care about? This is the next question. It's often that we can store all of this information. We might want to set up some basic alerts on the kind of things we care about that we're seeing in Audit D, say root activity or failed logins or even system shutdowns or different events. But one of the really important things to consider is security insights become incredibly important. I mentioned on that first slide that I've looked at about 100 billion events across many, many different production environments. And I wanted to share with you today one of the insights that we found. One of the frameworks that we've used at CMD to gain insight into what people do on the systems when they're running them is an open source framework called the MITRE ATT&CK framework. It's effectively a taxonomy of different threats, tactics, techniques, and procedures that adversaries are going to use to attack your infrastructure from a host perspective. And it's not only the kind of things that you're going to pick up as potentially unwanted or potentially bad. These are, especially in stages, linked to very advanced adversaries that might be targeting your infrastructure today. And with the prevalence of cloud and the ease of the ability to spin this kind of infrastructure up, TTPs are more important than ever to really monitor and watch for. So looking at this visualization on the right here, not only did we find that when we checked and analyzed a lot of those events, that file permissions, file deletions, and disabling of security tools were the three most common event types in adversarial behavior, we were able to find different ways to apply this to open data sets as well. Now, you might have been thinking about how you do this yourself, even without CMD, even without other platforms that are out there. Thankfully, there's amazing open source technology made by an individual by the name of bfuzzy on GitHub. It's a fantastic policy level approach to applying TTPs based on real world scenarios. You want to capture an event about local job scheduling or user execution or even process injection. These rules are going to give you at least the building blocks to build upon yourself and forward those events to a system where you might be able to alert upon them in the future. And look, if you're interested in looking at different ways to apply these on your own, Audit D frameworks are very easy to shift and change. And in test instances, I was able to get Audit D attack running up and running in a couple of minutes. Now, I will say they are a little bit rudimentary, but they're easy to build upon. And one of the most important tools that I found to build upon these rules is an even more powerful set of platforms, systems offered by a company out of, I think out of the East Coast of the US, but building fantastic tooling, a company called Red Canary, with an open source tool set that they've built called Atomic Red Team. How do we understand what an adversarial attack looks like when we might not be adversaries ourselves? So we've got the visibility set up. We might have applied some of those Audit D policies. With Atomic Red Team, we can run some of those policies on a single piece of infrastructure and gain a bit of understanding about what kind of policies might actually fire for us. What are the reactions to this? Can we block it? Can we stop it? There's definitely some work to work out and polish these kind of things, but one of the big things that I also wanted to mention was looking at adversarial behavior can go far beyond MITRE ATT&CK. One of the other fantastic free and open source resources that I found for this is GTFO bins. The ability to look at ways that adversaries are going to get a little bit more advanced, a little bit more creative with the kind of shell interaction that's going on within your systems, and actually try and evade some of the controls that you might have built out. So if you're going to test Atomic Red Team, I'd highly suggest you go out and check out the GTFO bins project as well, because leveraging them together can tell you if you've got a comprehensive control or just more of a high level, check the box control. This is really kind of tied to the kind of end goal of all of this, though. This is a quick screenshot of what it would look like in CMD, but again, it would look very similar in Elasticsearch and other products that are completely open source and free. When we look at attack tactics, techniques, and procedures, we want to look at the kind of things that are going on. And when we can tie them back to real human events, it builds a very complete picture around what might have actually happened on the system. Going back to the log that we saw sent out by Amazon and just the bytes sent and received, wouldn't it be fantastic to know the binaries, the files, and the tools and technologies that we use to exploit that system in the first place? Simply using some Audit D, applying some different consistent rules, and really kind of even looking at some more advanced technologies can get you really, really far ahead. But it doesn't just stop there. We've got to think about how we can actually get preventative. Now, we talked a little bit about prevention early on. We talked a little bit about constraint and control inside the cloud platforms and the kind of console access that you can put in place that's provided by default. Now, Linux does have some controls when you're actually deploying a system that you can leverage. And one of the best resources that I've found is the CIS hardening guide. One of the biggest things that a lot of people will look at when they're approaching a new system or a new deployment is what can I start off with? What can I take from zero and increase my security posture on day one? Constraint and control is often going to start with really kind of getting those baselines configured, making sure the accounts are shut down, hardening and minimizing the services, shortening the network times, getting interfaces off the internet, even applying some constraints and controls outside of the host. But when we're looking at the runtime, it's important to consider the control types that you can have in place as well. Some of the things that we've often seen out there are PAM plugins or bastions or gateways to kind of monitor what people are doing on systems or what security tools are doing, or even identity access controls. Applying things like Duo security to your server is a really great way to do this. But there are also vendor-supplied allow and deny lists and role-based access controls that you can really look into too. Some really powerful and capable tools that are going to make it one tiny bit harder for that adversary to get into the host when they might find that password or credential. Really, this all begins by identity, though. One of the things that you'll find with many, many cloud service providers out there is that you're going to see an absolute boatload of adversarial behavior. I opened up an SSH port on a standard server today in GCP for a few hours, and within about 15 minutes, in the first 15 minutes of that server coming online, I had around 120 to 200 different failed login attempts, all using different usernames, different passwords, different credentials, different account details. But one of the common themes that we found was they were all trying to use password-based authentication. Simply disabling password-based auth is going to give you a far greater way to go through many, many facets of what an adversary is going to kind of try and attack you with. But really, the most important thing here is to not only try and minimize the kind of accounts that are used on the host, it's removing the ones that the adversaries already know about. For those that are familiar with tools in AWS and GCP, you would have seen the Ubuntu user when you deploy a Ubuntu system, EC2-user when you're logging into a system run by AWS. There's a whole bunch of really standard accounts that you've got to really pull off the host or minimize at least to a point where you can de-risk them. The screenshot that I showed you before was password-based authentication on a shared account that's provisioned by the cloud service provider themselves. While some of those controls have been improved over the last few years, it's a pretty tricky situation if you're not starting from identity at its core. And one last thing here is to really ensure you're not using password auth. The last thing that we want to do is make it easy for adversaries to brute force their way in, potentially try different password lists, and really, kind of honestly leverage password, restuffing or stuffing attacks from previous exploits or attacks that your engineers might have used and duplicated somewhere else. It's really critical that you implement things like key authentication or certificate-based authentication early on to make sure when people are getting into a host, they're doing so securely. And if something was to be compromised or even a little bit kind of tampered with, you can make sure you've got some controls in place that are going to stand the test of that adversary. One of the other things that I'd also love to bring out is going beyond just those identity best practices. With PAM plugins, we can start to do some cool things with user sessions and interactivity. But the one thing I will say is when you do start to mess with PAM, you do pose yourself a pretty big risk of locking yourself out of the system. Any kind of deep security control within Linux, SE Linux, AppArmor, or the pluggable authentication model at its core are going to provide you very deep capabilities to start to get in the way of very specific system calls, very specific processes on the host that could break things very, very rapidly. So the pro tip of today is to leverage any PAM test you're going to be doing on an arbitrary, safe, and easy deployed, easy thrown away system. I'd highly encourage you to play with PAM very, very, very carefully. Unless you're an expert, you probably are likely to make a mistake the first few times. And even then, we all make mistakes sometimes. There's tons of free and open source tools to add constraints at login, such as DuoPAM for small deployments that add simple two-factor authentication on very specific login events, all the way down to very advanced tools that you can use. Square has an amazing Sudo2FA product that lets you use some kind of cool console tracking and some multi-factor approvals in that case as well. But the most important thing to think about here is implement these thoughtfully. Because when you're making a change to an environment, if it's not just you using the system, PAM and subsequent changes on that host can really break deployment, automation scripts, a lot of different tools, and it's a consideration that you've really got to have. You've really also got to make considerations around non-standard shells or non-standard access, non-standard machine accounts. You're going to find things in your environment from adding the logging and the monitoring that you've implemented earlier on before you want to implement a PAM plugin. Often these controls are added a little bit later on in your deployment when you've got a bit more of an understanding about what's going on in the environment. And when they're combined with things like the MITRE ATT&CK policies, they can build an incredibly consistent picture around what's going on. When we get a little bit deeper though, it's not just about protecting entry to the host. One of the things that I'm often getting asked about as well is how we apply ACLs. Can we take a rule list? Can we take a policy? And can we apply it to a very different subset of users within the environment? Native Linux groups and users and ACLs are something that is to be absolutely marveled over. But what they don't offer right now is very, very specific kind of controls and constraints in real time. So it's important as you're building using native Linux controls, you're looking forward, you're thinking forward about the kind of people using the system. Training these rules and building these policies and implementing these models can be complicated, but it is something that you can gain a bit of trust with. There are easier vendor solutions out there, but it's important you kind of look to what you want to try and achieve. If it's a simple static policy around preventing root access or implementing some simple groups, there are plenty of facilities built into Linux already. What I'd also suggest within this one as well is ensuring that you've got really key backups and you're testing on non-critical systems. One of the biggest things that I've done is not used VI sudo and had to physically connect to an instance, put it in single user mode, get in as root, try to fix the file, restart the system, deploy it again because we needed that host back. When you're messing around with Sudoers, it's important to do it in a safe way. There are plenty of guides here. Again, I put some comments inside the deck here for folks that want to kind of follow up on this as well. I'm actually found that the open guide at AWS is a really great guide for implementing Sudoers restrictions, but there are a number of open source tools that you can do to kind of manage these as well. My one suggestion though, or at least another pro tip for today, is if you are going around and managing Sudoers policies, make sure you are doing it with config management tooling. So if something does go wrong or you do make a change, you are able to revert it, but make sure you're not leaving the keys laying around for those config management systems in the first place. If you're creating a bit of a hole in the armor to make sure that that tool can go and manage a Sudoers policy, make sure it's locked down, make sure it's treated safely. And obviously as part of the course, also make sure you're ensuring that any kind of user provisioning or user management scripts and tools that are going to be used alongside these are going to put users in the right groups. I call out GCP on this one specifically because Cloud Shell access is something that's fantastic, but when it provisions a user into the system, it's provisioning that user with sudo permission. So look at it over time, make sure you've got track of these, and obviously look at your reporting and records to make sure that things are consistent. So, just to kind of wrap things up in a more consistent way, I don't want to kind of give everyone a headache and tons of research to go and do. The things that I'd really consider is it really highly depends on how far you go down this journey in your own environment. You don't need to start off with very advanced, very expensive tools to gain really great value from understanding what people are doing in your cloud. You can take advantage of CSP native tools. You might even be able to take advantage of some of the host and logging tools that you've got in place today. While you might be able to not afford an IR team today with your current approach, you can definitely store these events for forensic analysis in the future because adversaries aren't detected overnight sometimes, and it's important to keep track of different things. One of the other things that I consider here is organizations choose to forward alerts to different storage systems and other event systems to do really advanced things. There's some amazing technology out there, including free and open source offerings from companies like Demisto that can offer you SOAR capabilities when used in conjunction with your audit logs. Let's say you want to tamper with a system and you want to see that system shut down after it's been tampered with. Again, there's some amazing orchestration tools that are out there and tons of videos online if you want to check out some really cool and advanced things that you can do. If you're getting into system hardening, like I was talking about towards the end of this presentation, it's super important that you think of additional controls, not just the key access, not just the provisioning, but what you can do to move the needle. Can I implement multi-factor authentication with the free Duo plugin? Can I maybe add some two-factor controls around sudo with the platform from Square? Can I use some vendor tools to get some insights? Things are going to be different for your environment. So make sure that not only are you doing this for today, but you're tracking in for the future. As things change, as things shift in your environment, the more you mature and build upon your security posture, the better you're going to be able to kind of react to adversaries in that environment. The last point I would say here is your mileage may vary when it comes to any security rollout. And I think the most important thing to consider here is there's no fast, quick, and easy solution to everything being solved overnight. There's always going to be a pain point. Leverage the tools that you can use on open source. Leverage your community, especially groups like CSNP, to make sure that you've got a number of folks on your side when you're asking questions or leveraging different conversations in different ways. But make sure you're talking to your peers in the community about the kind of threats that might be pertinent, the kind of tools that they're using, and the kind of things that you'd love to see. So I guess without further ado, I'll end it there with some questions. If you've got any questions at all for me, feel free to reach out today. I'm more than happy to also follow up via my email or Twitter if you'd like to send some other kind of messages through, or through the chat inside the window today. So thank you so much for the time. And that's it for me, Lee. Thanks again.
Thank you very much, Jake. This is awesome. everybody who attended. Thanks again for coming and joining us here. We've got a few questions to ask. And as well, I just want to know that I'm going to open up the poll that we have for CSNP. So grab that down at the bottom of the screen, the polling screen, please. But first question that we had come up here from Himanshu Arora. What is your thought, Jake, of using robotic process automation, RPA, technology in the IAM process? And what is the risk involved in automating processes using bots in PAM or IAM solution?
Yeah, great question. I'll come at this from a more generic kind of machine learning and statistical analysis approach, because this is how I've solved the problem around IAM role identification and kind of credential sprawl. There are a number of concerns around owning all kind of automation that you would do with security procedures. The best way to look at this is actually a fantastic presentation that was made by the head of security out of McAfee a number of years ago, talking about why security controls aren't necessarily just the panacea when they're rolled out. The best example of this is when security controls go overboard and overly lock down a system. The best way to kind of approach this, though, is in a very concise and concerted manner. When we rolled out a number of automation tactics for detection and observation at CMD, rather than just blocking events outright or saying you're part of a deny list now, we've actually implemented some multi-step or multi-stage authentication strategies that simply re-prompt for a multi-factor authentication credential. And this is something you can do with cloud service providers, but it is definitely harder in the console than it is inside the shell. When it comes to PAM and actual rollouts of those kind of automated systems within instance, the other consideration to have is the sprawl and the nature of data that you've collected. One of the big things that we've noticed at CMD, just with our vantage point of a massive data structure or massive data set, is the kind of patterns of behavior that we see trying to abuse systems. So it's important to consider how verbose your data set is, how many features that data set is, how biased that data set is, because there are going to be some concerns that you run into. More than happy to go into this one in a bit more depth, though, because it was a great question. And I absolutely love that kind of question coming through. ML and artificial intelligence is actually something I'm really, really excited about, especially as it comes to security. So if you've got some pointers for me, I'd love to hear them as well.
Awesome. Second question we have is, I am in a cloud infrastructure, the responsibility of DevOps or a SOC or corporate IT, and how should we be thinking about it?
That's another really good question. You know what? I've seen it managed in multiple organizations in different ways, but I would bring up the kind of topic that I see kind of used in the database world. Never have two accountable parties for responsibilities around audit, responsibilities around constraint or control, especially when it comes to IAM. If IT is managing it, IT owns the stack up and down. If security is managing it or SecOps is managing it, make sure they own the stack up and down, and set accountability and control points in other parts of the organization, if you have the ability to do so, to audit those controls on a regular basis. When control and obviously the kind of main points around IAM are delivered amongst multiple people, or there's the kind of multiple point situation where everyone's pointing the finger at everyone else for kind of letting the account sprawl grow, we end up with gaps in our coverage, and that's not good for anybody. So while I wouldn't recommend any specific part of your organization, you're going to have different parts of your org that are going to be more effective or less effective at controlling that kind of infrastructure, or that at least the policies within that infrastructure. I'd highly suggest a single organizational owner, a single executive owner of those policies, and a single audit process for managing those policies moving forward. Make sure you're doing it continuously, make sure you're following best practices, and make sure someone's accountable for it. That's maybe the best advice I can give on that front, other than, I guess, without knowing more about the environment.
Awesome. One more here. Are there any open source scripts that you can recommend to be used on large or on small or large scale deployment of cloud environments to identify configuration discrepancies?
Yeah.
Such as all those things that are in the Q&A.
I'll scroll up a little bit. One of the interesting things here is, there are definitely tools and kind of procedural, kind of things that are out there. But I will say this, there is nothing better than really understanding your environment. I will say there is one caveat behind that. Looking at points in time forward is only a vantage point that you can trust for a certain amount of adversarial attacks. If an adversary has landed in an environment and is dwelling in that environment over time, looking at, kind of automated scripts and tools can be very powerful way of detecting gaps within that infrastructure. There are a number of offerings out there. I've mainly used the commercial ones because I've found them most effective, but looking at Rapid7's product offerings are really effective, but can be quite expensive if you have a larger fleet. We've integrated with a number of their solutions, both from log consumption, kind of comparison in different SIEMs and SOARs, different SIEM platforms out there when people are looking at who changed a file and where that file might have actually been changed down the road, or prior to that kind of change being made on a system. But there are a number of things that you've got to kind of take into account with any of this. There's no silver bullet, unfortunately. Observability, I love to kind of pitch our own product, but it is a commercial offering. So there are other Linux products out there that are open source that might make log capture and log event capture a little bit easier. If you're not a fan of Vector for kind of ongoing system and audit activity, the Audit Beats framework from Elasticsearch is a great one, but again, it's not fully open source and there are some commercial kind of trade-offs there as well. So hopefully that gives you a little bit of an insight in what some of those details might be.
Great, thanks a lot, Jake. Johnson, I want to throw one over for you to ask. You want to unmute yourself. You had a question there.
I think, can you hear me?
Yes.
Loud and clear.
All right, good. So I think I posted like 10, Jake. So let me pick the best one from here. So you mentioned something about CIS controls and hardening and all that stuff. So in my experience, what I found with that is they're very voluminous. You just toast into a website to look for yourself what you want to adopt. Do you have some kind of shortcut recommendation in terms of determining what is easiest to pick from that vast database of CIS?
Yeah, that is another really good question. One of the things that I've actually found really helpful, Johnson, is going beyond very specific controls and looking at ways you can automate deployment of something like CIS. There's the CIS priority guide on the website to tell you the kind of ways to prioritize the controls that you should put in place on your host. For a deployment of those hardened systems, one of the sites why this screen just came really bright for me is actually the Ansible CIS benchmark that's released in an open source fashion that'll let you deploy CIS to an existing host. But one of the easiest ways to get started with host and instance hardening in a really great way is actually leveraging a number of the CIS hardened instances that are available in cloud. I'm sorry I forgot to mention it, but Amazon, GCP, and Azure have capable instance deployments of Red Hat, CentOS, Debian, Ubuntu with CIS guides pre-hardened on those systems. So you can actually start, kind of a couple of months in if you're starting with a brand new deployment. The good question that you asked as a second part to that was really, how do you do this in a staged approach? Really, it's about understanding the marketable risks to your vertical. So one of the slides that I presented earlier on, industry-specific risks. Are insider threats a large problem? Well, great. Let's look at identity. Let's look at access. Let's look at accountability. If adversaries and APTs are a major part of the strategy, perhaps you look to EDR vendors, antivirus vendors, and potentially those identity vendors as well to kind of build a compartmentalized strategy around how you defend the system alongside something like CIS. But I think without kind of speaking, to people's specific situations or giving any bad advice, it's going to vary, and it's going to be pretty much tied to the kind of things that you're going to need to prioritize in your environment. Is the best way to think about it.
Awesome. All right, let me just ask one more. I know we only have a minute left. You talked a lot about the stack. You mentioned stack quite a bit. But then there's also this other word or term that we hear, which is the hypervisor, especially when you're getting services from an outsourced provider. So where does the hypervisor responsibility start for the end user? Is it above or below that?
Yeah, really, really interesting one. This has actually come up a number of times when companies like Rackspace or Amazon have patched hypervisor level vulnerabilities and code execution. Probably the most famous example about this is when cloud melted down a couple of years ago with the Rowhammer attacks for shared infrastructure.
Yeah.
It highly depends on the level of infrastructure as a service, platform as a service, or SaaS, software as a service provider that you're leveraging. One of the big things that I would say is understanding that line of delineation is going to depend on the service you're using. So if you're using Compute Engine, you're going to go all the way down to the level above that hypervisor. If you are leveraging something like IBM's soft cloud offering, you're actually provided access to even some of those underlying infrastructure components as well. And you're effectively allowed things like IPMI, or at least in the early days you were, to get onto those systems and do different things. So the line of delineation depends on the cloud service provider. But one of the things I'd actually reference here is the best practices guide from Amazon and Google both include that delineation guide, and it'll actually tell you where your responsibility starts. When you think about the hypervisor specifically, though, it's a great question because the hypervisor can be this ambiguous term, especially if you're not using a tier one, kind of cloud service provider. Sometimes they might tell you not tell you what's going on underneath. So it's important that you not only look at the cloud service provider's reputation, but also what standards they adhere to, what kind of things that they do. Do they have SLAs around patching or availability or even privacy? Are there things that are excluded from those lists as well? And it's easy to read through them. Anyone can request the SOC 1 or SOC 2 reports from Google or Amazon, but it sometimes takes a little bit of purchase power, but it's something that you should definitely look into.
Awesome.
No worries at all.
Good stuff.
Well, thank you very, very, very much, Jake. Also, Jake, would you just like to quickly mention something that CMD is going to offer attendees tonight?
Oh, of course. For those that have joined today's webinar and for those that have signed up, I'm really, really looking forward to having your feedback about my presentation. Love the feedback and obviously would love to improve these sessions as well. But one of the things that we wanted to offer was early access to our completely free product. So part of our contributions back to the open source community and obviously the security community in general is giving a lot of these observability tools away for free for small environments to let you play with, to let you try and learn different things. And so if you want to check it out, I've put the links inside the presentation. Blake Mitchell is actually in the chat as well if you've got some questions for him as we go. And I think he's included some links to both the CSNP link on CMD that you can get into that trial pretty quickly. And we'll have you in, you'll be up and running with alerting and monitoring pretty quickly. So happy to and really excited to share that with the community today too.
Awesome. Sounds good. And yes, we will be sending out same thing by email to all attendees, so you'll have it there as well. Again, appreciate it, Jake. We're right at the nice cutoff time, and we love to have things start and end on time. So again, thank you very much. We cannot wait to have you back. You will be one of the featured speakers and panelists for CSNP Toronto for sure. And I know CSNP as a whole would be pleased to have you continue to speak and give your knowledge.
No, appreciate it. Thank you so much. It's great to be part of the community. Absolutely love to give back where we possibly can. And look, thank you so much for the venue to kind of share some security information. It's awesome to get these insights out there. I'm excited to see what people do with it. And hopefully they take some of this insight and kind of change their own stack as well.
Awesome. Thank you very much. And with that, we will end this Zoom webinar. Thank you everybody for attending, for the questions that put out, for filling out the poll. And of course, my panelists that joined me here, thank you so much for helping out and making this a success.
Thank you. Thanks everyone.
Thanks again, folks. Appreciate it.
Bye-bye.
Bye.